Imagine standing on Earth, but everything around you is frozen. Not just your city, not just your country, the entire planet. Oceans turned into glass, continents buried under ice sheets more than 2 kilometers thick, temperatures dropping so low that even the equator looked like Antarctica. It sounds impossible, but it happened more than once. Welcome to the most extreme chapter in Earth's history, the time when our world became a literal ball of ice. So what could freeze an entire planet? And more importantly, how did life survive something so brutal? To understand that, we need to travel back, way back, to a time long before dinosaurs, long before complex animals, long before plants covered the land. We're going to the Cryogenian period, between 720 and 335 million years ago, when Earth experienced the coldest climate events we know of. But let's start with the mystery, because the first hints of Snowball Earth didn't come from ice, they came from rocks. In the 1960s, geologists in Namibia and Australia found something strange. Glacial rocks, the kind that form when huge sheets of ice grind across the land, were sitting in places that used to be near the equator. The continents, thanks to plate tectonics, had moved since then, but these rocks weren't lying. They showed that ice once reached the tropics, a discovery that made scientists ask the impossible. Did Earth freeze all the way to the equator? The idea sounded crazy, but more evidence kept appearing. Dropstones, rocks carried by icebergs and dropped into ocean sediments, were found in layers that formed in warm tropical waters. Ocean chemistry records showed massive shifts, like the world ocean suddenly becoming low in oxygen. It all pointed to a dramatic global freeze. Still, the big question remained. How does a planet fall into a deep freeze so complete that even the oceans lock up? To answer that, imagine Earth's climate as a thermostat, sensitive, delicate, and always adjusting. Now, imagine turning that thermostat just a little too far. Scientists believe Snowball Earth began with a chain reaction, a volcanic eruption, a continental shift, or long-term changes in the atmosphere. One major suspect is reduced volcanic carbon dioxide. Volcanoes release carbon dioxide, which traps heat, but if tectonic movements reduce volcanic activity for long periods, CO2 levels fall. Less heat means more ice, and more ice means more reflection. Ice reflects sunlight back into space. The more ice forms, the more sunlight is bounced away, making Earth even colder. This is the ice albedo feedback loop, and once it begins, it's almost unstoppable. Imagine a snowstorm that never stops growing, a freeze that feeds itself, white spreading across continents, oceans locking into packs of sea ice that reach hundreds of meters deep. Scientists estimate that global temperatures may have dropped to minus 50 degrees Celsius in some places. Even CO2 dissolved in the oceans began to freeze out. The world became quiet, still, almost dead. And life? Well, life was hanging on a thread. Before Snowball Earth, life was simple, mostly microbes, cyanobacteria, single-celled organisms. Nothing complex, nothing with a backbone or even a soft body. Just microscopic survivors. For years, scientists believed Snowball Earth should have wiped everything out. A frozen world means no photosynthesis, little oxygen, almost no liquid water. But life found a way. Recent studies offer powerful clues. Microbial fossils found in Australia, China, and Canada show that life hid in refuges. Cracks in the ice, warm volcanic oases, and thin layers of ocean that remained unfrozen under thick sheets of ice. Hydrothermal vents on the sea floor kept small pockets of water warm. Chemical energy replaced sunlight as food. Life shrank, adapted, and endured. This survival is one of the greatest miracles in the history of our planet. Because when Earth finally thawed, everything changed. But how do you thaw a frozen planet? The answer is dramatic. When oceans freeze, volcanic carbon dioxide can't dissolve into the water, so it keeps building up. Imagine millions of years of volcanic eruptions pumping carbon dioxide into an atmosphere that traps everything, like a sealed bottle. CO2 levels may have reached 350 times higher than today's levels. NASA climate models suggest this greenhouse effect became so extreme that the planet suddenly flipped. Ice began to melt, clouds formed, runaway warming kicked in, and then the Great Melt. Ice that had covered continents for millions of years collapsed. Glaciers retreated, sea levels rose rapidly. Oceans turned from dark blue to a sudden milky white as minerals dissolved and reacted. Geologists call these rapid deposits cap carbonates, a fingerprint of a world reborn. Earth went from deep freeze to tropical warmth, and this transition wasn't slow. Some studies suggest the melting could have happened in less than 2,000 years, a blink in geologic time. What followed changed everything. The newly warm oceans became rich in nutrients. Oxygen levels began to rise, and life, after spending millions of years as tiny survivors, began to transform. Many scientists believe Snowball Earth set the stage for the Cambrian Explosion, the moment around 541 million years ago when complex life suddenly appeared. Creatures with eyes, limbs, shells, nervous systems. This is when evolution hit the accelerator. Without Snowball Earth, the story of life might have been very different, maybe slower, maybe less diverse, maybe not even capable of producing beings like us. But there's another question hidden in this story, one people don't ask enough. Could Snowball Earth happen again? Modern climate science says not really. Not with the current levels of solar heat. The sun is brighter today than it was 700 million years ago. Earth receives more energy. That extra sunlight makes a global freeze extremely unlikely. But surprisingly, some scientists have warned that regional small snowballs could happen if extreme volcanic eruptions or asteroid impacts triggered sudden cooling. Not a full Snowball Earth, but a severe mini ice age. And then comes the biggest twist. Ironically, today's problem is the opposite, a runaway greenhouse effect. Humans pump more than 37 billion tons of CO2 every year into the atmosphere, according to the Global Carbon Project 2023 report. Instead of freezing, Earth is warming faster than at any point in at least 125,000 years, according to multiple NASA and NOAA studies. The danger now isn't too much ice, it's too little. But Snowball Earth still matters. It reminds us that our planet is fragile, that climate can flip from one extreme to another, that life can survive unimaginable hardship, but not without limits. Most importantly, it reminds us that Earth's history is full of miracles. Miracles that made our existence possible. What other secrets does Earth still hold beneath its frozen past? And will we ever face another climate tipping point of our own making? Think about it, and let me know what you believe in the comments.